Thanks everyone for attending. I know last time I talked to you guys about all this was the last live DREGS meeting, and about 2 weeks after that, the lockdown started happening. But despite the pandemic, Eskay Mining has had a very productive 2020, and I'm going to share tonight our results from 2020 and some of the stuff that we're going to be doing in 2021. So just a quick disclaimer, it's the required slide saying that I'm going to be talking about forward-looking statements and all that. So this is just legally required for me to say. We'll get started talking.
John, you're muted.
You're muted, John.
He can't hear.
John?
John.
There, am I unmuted now?
There we go.
Okay, yeah, I clicked that 3 different times. Let me go back. All right, so I'd like to talk to you tonight about Eskay Mining's exploration program in 2020 and what we're going to be doing in 2021. Do have to share this disclaimer slide with you if we're going to be talking about forward-looking statements, etc. And this is just a legal requirement. But talk about Eskay Mining's property. That's outlined here in gold. It's in northwestern British Columbia in the heart of the Golden Triangle. We have several notable mineral deposits surrounding our property, foremost of which is Eskay Creek right here, which is world-class VMS deposit. We also have Garibaldi's E&L deposit. This is a magmatic nickel copper deposit. Seabridge Gold's Iron Cap and KSM deposits. These are gold-rich copper porphyries. And then we have Bruce Jack, Valley of the Kings, which is an epithermal, and then the Treaty Creek deposits up here are VMS deposits. And then you can see on our property, we have several different gold deposits around the property, the majority of which are VMS, or volcanogenic massive sulfide deposits, with the exception of Red Lightning, which is it's a magmatic nickel copper deposit. So we're in a very prolific district. So focusing on VMS deposits in particular, I'd like to share this diagram with you showing the deposit tonnage on x-axis and gold grade on the y-axis for several VMS deposits that have been mined in the past. Draw your attention to these gold-rich deposits here, foremost of which is Eskay Creek. While it is a relatively modest tonnage deposit, it is a very high-grade deposit, actually one of the world's highest grade gold deposits. And that allows it to be up into the 100 tons gold category, along with some of these other world-class but larger tonnage deposits. Most of these are in the Abitibi district in Quebec and Ontario. And that's an important thing to consider when you're exploring for VMS deposits, is that these don't really occur in isolation, but they do tend to occur within districts. Why do they occur within districts? Well, to understand that, I have to talk a little bit about the genetic model for VMS deposits. And this is a cross-section from Thomas Monarchy. So these VMS deposits occur in submarine extensional environments. The deposits I'll be talking about today formed within a back arc rift environment. So you have this submarine environment with these extensional faults right here that will facilitate fluid flow from the seafloor down into the subsea floor environment. And as these fluids are penetrating into the seafloor, they're becoming modified through fluid rock interaction. This is where the metals get picked up in into these fluids, and then these fluids ascend over the rift-related intrusion right here, and these heated fluids ascend up the, again, more volcanic extensional faults where the fluids vent onto the seafloor. And it's this drastic change in temperature from about 350 degrees Celsius for high temperature VMS deposits to 2 degrees Celsius that's causing the precipitation of metals. It's a thermally controlled or temperature controlled precipitation of metals onto the seafloor. It's important to note, though, that this upflow zone right here with these hot fluids will intensely hydrothermally alter the host rock and also precipitate stringer style mineralization in this upflow zone. So looking at modern examples of hydrothermal systems like VMS deposits, you can go to the Juan de Fuca hydrothermal field off the Pacific Northwest coast of North America. And you see here that these are actual active hydrothermal vents, and they tend to occur along, again, these rift-related extensional structures and the intersection of these structures with the transform faults that offset rift segments. So this is something we see in the modern day, but it's also something that we see with ancient deposits. For instance, the nearly 2.7 billion year old Millenbach VMS deposit in Quebec and part of the Abitibi district, where we have these series of extensional rift faults right here. And then you have your transform faults that are cross-cutting these rift-related faults. And it's actually along both of these structures, and in particular at the intersection of these structures, where you'll get the largest deposits forming. So these things do tend to occur along structurally controlled trends. You also have the possibility of multiple horizons of VMS mineralization, and that's because these VMS mounds or these hydrothermal systems form during periods of volcanic quiescence. That is, the volcanism will tend to plug up or stop up the plumbing system of these hydrothermal systems. However, once the volcanism subsides, you still have that heat source and at the center of this rift, and that's driving these systems, and you have this volcanic quiescent period where the hydrothermal system becomes established and starts to precipitate sulfide minerals on the seafloor. Now, these tend to occur with mudstone. That's only because the mudstone is able to accumulate to appreciable thickness during periods of volcanic quiescence. So mudstones can act as a vector towards these VMS ore bodies, but they're not necessarily genetically related to these sulfide mounds. They just tend to both form during these periods of volcanic quiescence. So moving towards the specific deposit we're talking about, we'll start with Eskay Creek. This is our world-class neighbor. It is located, again, in northwestern British Columbia on the northwestern nose of the Eskay anticline right here. It's within a package of rocks that's collectively called the Hazelton Group. There's a lower Hazelton Group, which is arc-related volcanic and volcaniclastic rocks dominated by andesites. And over time, as they're getting younger, they start to become dacitic in composition. And then you have your upper Hazelton Group, and this is rift-related bimodal volcanic rocks. So you're actually getting more of your felsic volcanic rocks erupting, and then over time it becomes exclusively basaltic. And overlying all of this conformably is the Bowser Lake Group, which is a package of sedimentary rocks that is post-volcanic. So again, looking at the Eskay Creek mine itself, the historic world-class workings of the mine are here in the 21 zone on the northwestern nose of the Eskay anticline. And you can see here we have in green, this would be our basaltic rocks. And then in the pink, you have rhyolites, and the purple is denoting dacites. And the historic workings have been focused on this contact between the basalt and the rhyolite, where there's this mudstone called the contact mudstone. This is believed to have been a seafloor horizon that had active VMS venting onto the seafloor. However, the historic ore at Eskay Creek was not massive sulfide mounds, but rather clastic sulfides. These ores are believed to have been disrupted by seismic activity, where you basically destroyed a sulfide mound and it was redeposited by a channelized debris flow into these clastic sulfide deposits, where there is a gradation in grain size, or it's believed up here would be the northern part of the deposit, where you have your coarser grained material, and then working down towards the southwest along the limb of the anticline. But the anticline didn't exist at this point, since we're talking about a submarine environment. But it gets to finer and finer material until it's disseminated. So they are able to infer that there was some sort of sulfide mound up towards the northern part of Eskay Creek, and the debris flow, was channel fed and deposited this material off towards the modern southwestern part of the deposit. So moving on to our property, Eskay Mining's property, we'll start talking about the SIB property. So here again, we have our Eskay anticline. And as we proceed along strike along the western limb of the Eskay anticline, you'll go through the 22 zone. So I should note that Eskay Creek is currently being operated or explored by Skeena Resources, and they've expanded upon the historic workings and have found the 22 zone, which again is more of our contact mudstone hosted mineralization. The Tamakai zone, which is immediately adjoining our border. And I'll talk about this a little bit later, but this is actually at a lower stratigraphic level than the contact mudstone. And then this white outline here is our property, where we control some enclaves along strike on the Eskay anticline right here. And then when we get down towards the Lulu zone, this is where our property opens up. And I should note that the SIB and Lulu zones are in a joint venture with Kirkland Lake, with Eskay Creek or Eskay Mining Corp controlling 80% of the project. So we do have SIB and Lulu are right along strike along the western limb of the Eskay anticline. And it's worth noting that up here around Eskay Creek, the contacts are dipping about 30 to 40 degrees, and then proceeding towards the south along the limb of the anticline, the contacts steepen to near vertical when you get to our property. And there are a series of en-echelon strike slip faults offsetting everything on the anticline towards the east as well. So a lot of the history of exploration on this property has been stymied by incorrect geological interpretations, notably with the Coulter Creek thrust fault. So this is a major thrust structure along the west limb of the Eskay anticline that has been historically considered to be an east-dipping thrust fault. I'll say that the people who worked on this project in 2017 and 2018, they worked for CJ Gregg and Associates. It's a consulting company we still use. They realized that that didn't make a whole lot of sense. The west or the east dipping thrust fault just really wasn't jiving with what they were seeing in drill core, where you actually have this kind of wedge of Bowser Lake sediments with this Hazelton group of volcanic rocks lying on top of it and below it. So it's inferred that perhaps there was some sort of angular unconformity right here between the Bowser Lake group and Hazelton group rocks. However, this doesn't really agree with the regional geology, where Bowser Lake group is in a conformable contact with the basaltic member of the Hazelton group, and it doesn't really occur in contact with the rhyolite at all. conformably. So that got me thinking last year, perhaps this thrust fault is dipping to the west. That would make a whole lot more sense given the tectonic environment that we're in, where we have terrains accreting from the west onto the western margin of North America. You would expect to have a lot more of your major thrust structures dipping towards the west, with subsidiary back thrust structures dipping towards the east. So that was one of the first things that I investigated when we went up into the field last summer, was to look through the historic drill core and really try to identify the nature of all of the contacts between the Bowser Lake group and the Hazelton group, using this redrawn geologic map as a guide, where I basically flipped around the orientation of the Coulter Creek thrust fault to the west, noting, which I'll talk about, that there is a wedge style back thrust that I'd hypothesized here for the Lulu zone. So this is just a rough, non-reconstructed cross section I drew up based on a leapfrog model of all of our drill core and lithologies and drill core, and it does indeed show that we do have this Bowser Lake group wedge kind of shoved into our Hazelton group rocks. And what I'd proposed was that our primary thrust structure is actually a west dipping thrust fault, and then we do get our smaller east dipping subsidiary back thrust structure. And you're even able to see, just with looking at the drill core, that there really isn't that much in the way of offset along this back thrust structure, no more than 50 meters of offset, where the Bowser Lake group, there's a significant amount of offset in order to get that into a contact with the Eskay rhyolite. And then this wedge structure, again, really only occurs along 900 meters of strike length near the Lulu zone. The majority of the strike length of the Coulter Creek thrust fault is just a simple west dipping thrust fault. So what did I find when I looked at the drill core? Well, in every single case, every contact between the Hazelton group and the Bowser Lake group that we'd intercepted with the historic drill core shows a fault contact. And in particular, we do see that west dipping thrust fault contact. This is representative drill core of that contact, where I'm starting about 20 meters above the fault contact with the Hazelton group. We have Bowser Lake group sedimentary rocks exhibiting very small micro faults and small offsets that you can see here in this picture of the drill core. Proceeding closer to the fault zone, you start to get some brecciation. And then the fault zone proper is characterized by a mixture of basaltic clast here in this kind of green-gray, the more of a paler gray or rhyolite clast, and then the ground mass of this fault is ground up Bowser Lake material. So what we're actually seeing is a melange or a mixture of both the Bowser Lake group and the Hazelton group at this fault contact, as well as a reduction in grain sizes, a lot of cataclastites on this contact. And this characterizes every contact we found with this, between the Bowser Lake group and the Hazelton group. So we were able to show pretty confidently that, yes, this is indeed a fault contact. It's not some other type of contact like angular conformity, for instance, as some people had thought previously. So I have to think about the proposed tectonic events at SIB, because this was a big critique from some of the older geologists who had worked up there previously, that you can't have a thrust fault that's displacing older rocks over younger rocks. That just isn't the way thrust faults work. I guess, if you're thinking about things in a geology 101 style of thing, in undeformed rocks, that is correct. However, we are dealing with deformed rocks. So to start off with the tectonic history, we have our arc-related volcanism related to subduction. This would be represented by the Betty Creek Formation, Inuk River andesites. And then slab rollback starts to initiate back arc rifting, and we get the deposition of the Spatsizi Formation on top of the Betty Creek Formation. The Spatsizi Formation is a package of volcaniclastic sedimentary rocks, mostly sandstones and conglomerates. And then you get the inception of rift-related volcanism. This is where we start to transition towards a strictly bimodal style rift volcanism, where we have our initial felsic to dacitic units, and then our full-blown rift-related volcanism represented by the Eskay rhyolite with subsidiary amounts of basalt, and then over time becoming more and more basaltic until it's dominated by basalt and exclusively basalt. And it's during periods of volcanic quiescence during this rift stage that you're getting your hydrothermal system set up and the deposition of the contact mudstone. So this is our mineralizing episode here. Following the volcanism, you still have a submarine basin, and this is where the Basel Lake Group sedimentary rocks are deposited conformably on top of our Willow Ridge basalt. Continued accretion of terrains to the western margin of North America deformed the rocks that I've described above. So we're forming our Eskay anticline, and then after the anticline is formed, thrust faulting occurred, and that's displaced our younger Basel Lake Group over the older Hazelton Group volcanic rocks. So, you know, if you have the condition where you've deformed your stratigraphy first and folded it, and then the thrusting occurs, you can get these younger rocks thrust up on top of older rocks. And this is exactly what we've seen up here on Eskay Mining's property. So we've done a very detailed chemostratigraphic study. We found with a lot of the historic work up here that the rocks were improperly identified the majority of the time. And since we are dealing with strata-bound deposits, it's really important to know where you are stratigraphically. So we've did a chemostratigraphic study by looking at some of the data from previous drill programs, in particular here, the immobile elements titanium and aluminum. We're able to see that we have several different populations of rock. There's kind of pinks and grays here. These would be our, the grays are andesites, dacites. So this is our volcanic arc towards our transition towards rifting, is represented by these kind of intermediate composition rocks. And then the yellows over here on the low titanium end are rhyolites. And then the basalts are over here in black, and these are the high titanium ones. And there does seem to be three populations of basalts that tend to become more titanium rich over time. These results agree very well with previous results by Barrett and Sherlock at Eskay Creek in 1996, showing a similar range of compositions. And interestingly enough, using data that Samuel Pierre provided me from Matagami in the Abitibi district, you know, even though these rocks are 2.7 billion years old, we are still seeing that same initial arc-related intermediate signature followed by our bimodal rhyolite to basalt signature, showing that even 2.7 billion years ago, the same tectonic processes were active at all of these VMS showings. Continuing with the chemostratigraphy, we've used other immobile elements to distinguish our rock types across the property. Niobium yttrium over zirconium titanium is a very helpful way to distinguish all the different rock types we have, in particular working on distinguish our dacites from some of our rhyolites. These do appear somewhat similar in hand sample. And something that's going to be very important for field work is using titanium and zirconium because these are two elements that can be analyzed with the handheld XRF unit. So Eskay Mining has purchased 2 of these Bruker XRF units to supplement our core logging and to serve as a quality control on the identification of these rocks in the field. Since we will be drilling upwards of 30,000 meters of drill core, we need to make sure we get all of this identification done properly. Another thing that we've been doing with geochemistry is looking at the alteration index. This is something that has gone overlooked in the district for the entire history of working up there, really. I'd say that one of the previous operators on the property walked away from the project because they were just using sodium versus sodium-potassium ratios to assess or evaluate the intensity of alteration. And that's really literally is a one-dimensional view of alteration in a VMS system. VMS systems are characterized by a zonation of alteration around this feeder zone and proximal to the ore zone, which includes alteration minerals such as epidote, calcite, dolomite, anchorite, chlorite, pyrite, cerussite, and potassium feldspar. So if you're looking at potassium and sodium ratios, you're missing almost all of the alteration minerals there. So utilizing Ross Large et al.'s alteration box plot developed for VMS deposits and something that Thomas Monarchy suggested that we do, we're able to see that we do indeed have very intensely hydrothermally altered rocks over here in this field. And you can see that the size of these dots corresponds to gold grade, with most of our gold grade occurring in intensely hydrothermally altered rocks, just as you would expect for a VMS deposit. So we do have very intensely altered rocks here, contrary to what previous operators had thought on the project. So I looked at several historic drill holes on the property to revise the stratigraphy, make sense out of it. And drill hole 02113 from the Lulu zone is one of these drill holes. So we're starting off in this hole up in the Eskay rhyolite here in the yellow. And then we have several of our elemental abundances down here in these columns. I will point out notably our gold here in yellow is what we're going to focus on right now. That we do have our rhyolite, and then there's mudstone layers within the rhyolite. So we have this pepperitic mudstone, and you can see here that it runs quite high with gold. In this drill hole, it gets up to about 50 grams per ton gold. However, other intercepts in the Lulu zone get up to 95 grams per ton gold, and it getting up into a couple thousand grams per ton silver within these zones. And then you'll see that there are several other smaller pepperitic horizons within this rhyolite that show high gold values as well. And then we'll note that this is not the contact mudstone. This is a deeper stratigraphic zone, and similar to something that Skeena Resources has drilled recently that they're calling the lower mudstone. And then they've also intercepted this along strike up at Eskay Creek. This unit they're calling the even lower mudstone. And we're going to be changing the terminology on these names because, as I'll show you, we've intercepted several additional stratigraphic zones, and you can't just keep calling something lower and lower and lower because it seems that these zones continue quite deep into the stratigraphy, much deeper than people had previously thought. So going down below these rhyolites and felsic units, we get into our Spatsizi Formation sedimentary rocks. I'll note that while this drill hole doesn't show any appreciable gold amounts, most of that's because it wasn't acid. However, other drill holes on the property do intercept quite high grades within the Spatsizi, up to 61.9 grams per ton. And I'll talk about that shortly. About most of the mineralization encountered within the Spatsizi Formation is associated with coarser grain conglomerate rocks. And we're inferring that this is because hydrothermal fluids are able to flow laterally within more of this clast-supported kind of network within these sedimentary rocks versus more fine-grained material that doesn't have as much porosity. And then moving into the Betty Creek Formation, we do see within this hole a few elevated zones of gold enrichment, notably associated with these dacitic breccia. I'll show you shortly that the TV and Jeff showings, which we drilled this year, we get grades as high as 84 grams per ton within these zones. However, this does go to show that even at the SIB and Lulu showings, we do get elevated gold within this, and it's possible that there is appreciable mineralization within these zones elsewhere along strike. Continuing deeper within the andesites, far deeper than has been drilled at the Eskay Creek property, we encounter additional mudstone hosted zones of gold mineralization here. And I'll show that what we see at TV and Jeff is very similar to this as well. And these are mostly replacement style mineralization where we're inferring the VMS upflow zone with these metal charged fluids did some lateral fluid flow along preferential horizons and actually was able to form some of these strata bound replacement style zones deeper down in the stratigraphy. So there are many more favorable horizons to look at than just the contact mudstone, which is above the section that's shown here. And that's really one of the new things in the district that both Skeena Resources and Eskay Mining Corp recognize as the increased potential prospectivity of these lower zones. And this is something that really wasn't appreciated over the past 30 years. Most people focused on that contact mudstone and ignored anything else. So looking at our approach to the Lulu zone proper, here what I'm showing is the approach to the zone where we have this pepperitic rhyolite. It does exhibit some foliation because we are dealing with a very low-grade green schist metamorphism and some shearing and deformation in the area. But you can see primary textures very well up here at SIB and Lulu. So we have our, kind of a pepperitic rhyolite with all this carbonaceous material till we get to a mudstone-dominated rhyolite pepperite immediately above our mineralized zone. And then the mineralized zone proper is this right here, where you have this kind of silicified mudstone breccia infilled with meargyrite, which is a silver antimony sulfosalt, and stibnite. And then going below our mineralization, we see again another pepperitic contact with the rhyolite. So now just looking at the paragenesis, we're able to, and the mineral assemblage, able to show that this type of mineralization here was actually near seafloor type mineralization where we had a hydrothermal venting nearby onto the seafloor. And then it was subsequently intruded into by this rhyolite and disrupted. And then, further up section, you would get the contact mudstone horizon again. So that would be our lower stacked horizon to the contact mudstone horizon. And then looking at some of the other drill core intercepts from another historical, we do get up to a meter of massive meargyrite and stibnite. This sample here runs 2,092 grams per ton silver and 20.5 grams per ton gold. And you do see this mixed in with a lot of barite. That is something that we've seen as ubiquitous barite and calcium alteration associated with the Lulu zone. So looking at electron microscopy to see the actual hydrothermal alteration, assemblage, and mineralization. What we see, again, our dominant silver mineral is meargyrite. That's just AgSbS2. And then we have our hydrothermal alteration assemblage characterized by celcium, that is a barium feldspar, and barite, along with a lot of calcite, and we do see some dolomite as well. So we are seeing a classic VMS hydrothermal alteration assemblage, and it's noteworthy to say that the meargyrite and celcium and barite are all consistent with a lower temperature, say below about 200 degrees Celsius hydrothermal system. And this is something that Thomas Monarchy has noted up at Eskay Creek as well, with your kind of arsenic, antimony, and mercury rich elemental suite that also tends to occur within low temperature hydrothermal systems. Turning towards the gold, what we found, there's a lot of arsenium pyrite, so it's quite likely that arsenium pyrite does play a host of gold, but we also have a good bit of electrum, which I have several examples right here, and the electrum's running about 60% gold and 40% silver. So turning now away from the Lulu zone, I move down section to our Spatsizi zone type mineralization. This is our drill hole EK 18160, which is up close to our northern border with Skeena Resources. And this is actually probably a continuation of a large zone of mineralization that they've recently made a press release about. But here we have within the Spatsizi formation several kind of felsic breccias. That's a very minor volcanic component within the Spatsizi formation. But along these contacts with these felsic breccias and these sandstones, we get some gold values, some of it getting as high as 61.9 grams per ton, again, in intensely hydrothermally altered rock. And then proceeding down section, this hole is actually drilling, up stratigraphy is down hole. As we get to the bottom of the hole would be where our contact mudstone is. And this was the boundary with Skeena Resources property. So we had to stop drilling, but we do start to see an uptick in gold values down there. So it's quite likely that there is additional contact mudstone mineralization down hole here. So looking at the auriferous drill core itself, here you can see we've just kind of got this sulfide replacement style texture of these conglomerates and kind of sandstones to conglomeratic sandstones right here, where you've got the sulfide kind of infilling the matrix, as well as some stringer style mineralization right here. We did a micro X-ray fluorescence mapping of these drill core, showed that we do indeed have our kind of illite and chlorite and carbonate type alteration assemblage, again consistent with the upflow zone of a VMS system. Looking at the actual mineral assemblages that we see within the Spatsizi formation, we do get beds of heavy minerals here. Again, we're dealing with volcaniclastic rocks. So what we see are apatite and euhedral pyrite crystals and rutile, all inferred to be magmatic of origin and the redeposited within these heavy mineral beds. You do get some traces of zircon and xenotime in here as well. However, when you start to look at the pyrite itself, what you see is that this original magmatic pyrite has been overgrown or replaced by hydrothermal arsenian pyrite. We also get some hydrothermal barium potassium feldspar occurring within these rocks, and chlorite and carbonate alteration. So again, consistent with our hydrothermal VMS system, kind of giving an overprint to this detrital magmatic rocks here. So you know, it's clear we've been able to show that the contact mudstone horizon, which is projected here below the Bowser Lake group, below our thrust fault here, is not the only game in town. We have our Eskay rhyolite mudstone horizon, of which the Lulu zone and the lower mudstone type showings that Skeena Resources is drilling at Eskay Creek are members of this Lulu zone, Eskay rhyolite horizon. And then we have our Bruce Glacier mudstone horizon, which we do see at Lulu zone, as well as other intercepts along strike on our property and at Eskay Creek as well. And then we have our Spatsizi zone mineralization, in which Skeena Resources has recently made a press release about their Tamakai zone. Our EK18160 hole that I just talked about would be right here. And we have numerous intercepts along strike within the Spatsizi zone showing auriferous mineralization. And then going below that, we get into our Betty Creek formation mineralization, of which we have some within our dacitic zones, and then further down in the andesitic zones. And I'll talk about this shortly, but this is similar to what we're seeing elsewhere on the property. So here's our schematic cross section of SIB, where we have our back thrust of our Bowser Lake group fault wedge. I like to imagine this as the Bowser Lake group. The sedimentary rocks are essentially the head of an axe that is splitting the log, which is the Hazelton group rocks. It's just like splitting a log, where you kind of get this wedge of Bowser Lake group material thrust into our Hazelton group. So I'll show you here. This is our Lulu zone right here, and a lot of drilling has been done in the shallow part, but directly below the Lulu zone, there hasn't been any drilling. Along strike, there has been 500 meters to either side of the Lulu zone. There's been drilling at strike to that depth below this fault wedge, but directly below the Lulu zone has never been drilled before. And we're proposing that there's a continuation of this Lulu zone, again, grading up to 95 grams per ton gold in the upper part. And that stratigraphy should continue under this fault wedge. This is supported by the fact that the two nearest holes that go down to that stratigraphic level below the fault wedge actually do intercept gold over a few meters. And what we found with historic photos is peperitic mudstones within rhyolite, exactly like what you see at the Lulu zone. However, historic logs indicated this entire interval was 140 meters of rhyolite. So a lesson to be learned is you really need to start splitting your lithologies a lot better than that, especially when you're dealing with stratiform horizons, especially these mudstones. You've got to identify this stuff and split it out. You can't just lump stuff into 140 meter intervals just because it's easy. You're going to miss stuff. And in this case, what we see is that we do have a peperitic horizon exactly where we predicted it would be below this fault wedge. So that's one of our targets this summer, is to drill directly below the Lulu zone and see what we have down here. The fact that, or the possibility that you could have additional mineralization is supported by the fact that we have further down stratigraphy several drill holes that intercepted gold mineralization, and it's indicative that we have a large upflow zone that is feeding our exhalative or C4 horizons here at the Lulu zone, and possibly even up section into the contact mudstone horizon. So, you know, as I've explained, we have our stratiform mineralization here at SIB. It's not just the contact mudstone anymore, but several different stratigraphic levels have this kind of stratiform gold mineralization. And then when you add on the alteration map, so in addition to just making our alteration box plots, I was able to use historic data plus several samples. We collected about 1,500 additional samples from historic drill core here, so I could make this three-dimensional model of our alteration halo here. And you can see with these kind of pinks and greens here, that is our intense sericitic type alteration. This would be the x-axis on our alteration box plot. And then these larger grayish areas are corresponding to our chlorite carbonate alteration here. And what we see is that all of these zones are associated with intense hydrothermal alteration. Again, consistent with VMS upflow zones. So I'm moving away from SIB, because that's just the west limb of the Eskay anticline, and for decades was considered the low-hanging fruit on the property. Just looking at the geomorphology from Leapfrog, sitting here in Colorado, was able to look at the geomorphic or topographic expression of these Hazelton group volcanic rocks and how they define these anticlines. And I started to say, I think these anticlines actually, or the Eskay anticline continues all the way south through our property, much further than has been mapped previously. So that formed a big component of our 2020 program. And recently, based on a lot of our work done over this past summer, was able to show that in addition to the Eskay anticline, we have two other anticlines on the property that are defining trends of high-grade gold surface samples and help identify or delineate where our really good BLEG samples came from that I'll talk about shortly. But we do have two additional anticlines that are cored by Hazelton group volcanic rocks. Up in this northern part, you kind of get an anticline syncline situation with some thrust faulting, and then down to the south is where we get our full-blown full thrust ramp complex right here, where we have our series of three anticlines kind of stacked or thrust up on top of each other. And this explains the occurrence of all the different mineralization or gold showings within our property, as well as within the broader district in general, which Eskay Mining controls 85% of. This is a brand new interpretation. I should note again that the historic geologic maps here had most of these thrust faults flipped the other way. The anticlines were either unmapped or didn't extend as far to the south as they should have. These are features that have been corrected recently by the British Columbia Geological Survey. So, things are starting to converge on our interpretation of the geology as being a series of full thrust ramps. This is very important for understanding, the dip, strike and dip of these features, because a lot of the drilling done to the south here is actually drilled parallel to the contacts or parallel to these beddings. So you'd intercept like 400 meters of basalt, when if you flip the drill around 180 degrees, you would have gone perpendicular to stratigraphy and actually found something possibly. So that's something we're going to be exploring this year. So moving all the way to the south on the west limb of the Eskay anticline, I do want to note our Cumberland showing here. This is a relatively small showing, and historic drillings only got up to about 11 grams per ton or so of gold. But it's important because this occurs at the contact mudstone horizon. This is showing that this Eskay Creek type mineralization occurs all the way to the south on our property. And we're talking nearly 15 kilometers along strike from Eskay Creek, and we're still getting these sorts of VMS style mineralization. And it shows that while this deposit has mostly been eroded out into the Sulphurets Creek right here, none of the drill holes really intercepted any of the deeper stratigraphy, so we don't know if we have any of our deeper feeder zone type mineralization here. And there's really no knowledge to the south, because this is where most of the drill holes were drilling the wrong direction and were basically drilling parallel to the limb of the anticline. So they just stayed within the same rock unit the whole time. So, probably a good idea to get out there with a Brunton and actually measure the strike and dip of some contacts before spending a few $1 million on drilling. So that's what we're going to be doing, is actually, focusing on the geology. So moving over to the TV and Jeff showings, let me back up real quick. That would be on the east limb of the Eskay anticline over here. So we're on the east limb of the Eskay anticline, kind of south of Sib and Lulu. And what we see here is that we've got some showings that have had previous drilling, and I was able to build a geologic model and interpretation based off of the handful of drill holes that were drilled here in the mid-1990s, and kind of using that Millenbach deposit from the Abitibi as a model. So what if we've got these stacked mineralized zones here? Just based off gold grade in the leapfrog model is able to show that, it looked like these auriferous zones dipped 45 degrees to the east and were striking 12 degrees to the northeast. And what we've seen in drill core supports this. We actually did our drilling here off to from the east to the west, trying to intercept this stuff as close to perpendicular as possible. And what we found indeed supports that. We have normally graded conglomerates and such going downhole. So our stratigraphic up is uphole or to the east here. We also did a SkyTIM conductivity survey of the region, which was able to show numerous conductivity anomalies, which, excuse me, which some correlate very well with known mineralization. For instance, here at Jeff, we see our auriferous zones delineated here in the kind of yellows, corresponding to this kind of reddish color right here. So we're looking at this kind of intermediate to high chargeability or conductivity anomalies, excuse me, that are corresponding with our mineralization at Jeff and TV. And it's worth noting that we do see several additional conductivity anomalies lying exactly along strike from TV and Jeff and having the same morphology and intensity. So we're inferring that these are sulfide zones here, more mineralized zones that have never been drilled before. Some areas up here, for instance, near some of these anomalies have been drilled historically in the past and do have some grades getting up over 1 gram per ton. So there's some evidence to support our hypothesis that these are additional sulfide bodies along strike from TV and Jeff. But in addition to that, so we're talking TV and Jeff on the east limb of the anticline. We have our western limb of the anticline over here, just along strike from Sib and Lulu to the north, have additional chargeability targets that are similar in morphology and intensity. And it's quite possible that these are additional sulfide zones on the west limb. So looking at TV and cross section, it's kind of a representative cross section for both TV and Jeff. What we see is that we are in the Betty Creek formation here. The grays are andesites. The browns are our pepperitic mudstones, and this pink color is our dacitic rocks. And most of the high grade mineralizations occurring within are dacitic breccias and pepperites. But it's worth pointing out that most of the drilling in the past has never gone any further up section than the Spatsizi formation. But it's quite likely that we do have our bimodal felsic volcanic rocks further up section. This is based off of the fact that there is a high bluff up section from the drill pads. It's never been mapped. However, it is consistent with the topographic expression of felsic rocks elsewhere on the property, where you do tend to form these bluffs and these rhyolitic to felsic rocks. It's also consistent with being stratigraphically up section from where we're drilling. And it's consistent with our IP survey that we performed in the region that shows, in addition to our known mineralization corresponding to chargeability anomalies, that we do have some chargeability anomalies up section that correspond as well to our skytim anomalies. So it's quite likely that we do have additional mineralization up section here at TV. So looking at some of the drill core from this season and historic drill core, all these core here were drilled in 2020. And what it's showing is the massive, the semi-massive sulfide that is replacing this dacitic pepperite. So we have our white to gray material here is our dacite, and then the dark material is our carbonaceous mudstone. And then this kind of all been infilled by sulfide mineralization, going again from a semi-massive to massive sulfide and disseminated stringer style sulfide. Looking through the electron microscope at a TV 9515, so this is a drill hole drilled in 1995, we're able to show that we do have a lot of euhedral pyrite. Again, just like at SIB, has been overgrown by arsenopyrite, and the arsenopyrite's actually starting to get some antimony enrichment towards the margins. We do have intense barium, potassium feldspar, and illite alteration as well. So we're looking at additional hydrothermal alteration, somewhat similar to what we see up at the Lulu zone. Looking at Jeff, this is just about 1.5 kilometers to the north of TV. We've got some really impressive numbers from the Jeff zone. This, if you paid attention to any of our press releases, this is the one where we've got, upwards of 30 meters grading over 10 grams per ton, with our highest grade intercept so far coming in at 84 grams per ton gold and 287 grams per ton silver here within this sample right here. Again, both associated with a pepperitic dacite, and we do see electrum here as well. This is an example from J2037, only 11 meters below the surface, where we have electrum, meargyrite, and pyrargyrite. So we've got our silver and gold minerals here. And this sample, while running somewhat low with gold at 4.7 grams per ton, is running at 804 grams per ton silver. And again, we were able to show using the alteration box plot that our gold grade corresponds very well with intense alteration. And I also do have some evidence from Jeff that we've probably intercepted a synvolcanic feeder structure where we have intensely brecciated rock, where the breccia fragments themselves are intensely chloratized and sericitized. And then you have your sulfide filling in this breccia. And then this breccia with the sulfide's actually been broken up by subsequent faulting. And again, just like we see at TV, we do have correlations between our mineralized zones and IP chargeability anomalies, except for this really large one down here. This is down section. This is actually Stuhini group Triassic mudstones right here, very carbonaceous mudstone that shows up on our IP surveys, but doesn't correspond to mineralization. However, these other anomalies up section do correspond with mineralization. So moving past, Sib, Lulu, TV, and Jeff, again, all of these that I've talked about so far have been on the joint venture ground, but going further south, we get down on the 100% Eskay Mining Corp ground. I've mentioned Cumberland briefly over here as showing that our contact mudstone horizon does continue to the south. But again, we can jump over onto the other side, the east limb of the Eskay anticline, and keep exploring over there. And we have several showings that again have been drilled to some extent in the past. And these are showings that I've done a lot of re-logging of drill core on over the summer to do lithogeochemical and petrographic studies to truly tease out the stratigraphy and structure on this property. So looking at our TET C10 showings right here, we're inferring that we've got a thrust fault in here that we're going to have to map out. That's going to be a big component of our 2021 field program, is mapping out the boundaries of these anticlines and where these thrust faults are. However, what we see on the surface and with our IP surveys is there is a structural trend striking 315 degrees. It's very apparent on the surface, and it's defining the southern extent of the Eskay anticline. And we do get quite good gold grades here with not only on the surface, but with historic drill holes. Notable, this one, Sierra 0517, intercepted greater than 100 grams per ton gold over 1.5 meters. We don't know how much over because they didn't run a fire assay after the fact, but this is something that we'll be able to test with drilling this year. So that would be our C10 showing right here, which does correspond very well with this large chargeability anomaly down here. Again, it does seem that we are getting this kind of strata-bound or structurally controlled nature to these chargeability anomalies. Worth noting that TET right here, which is just uphill from C10, where there's a silver sulfur salt vein outcropping on the surface. Historic samples have got up to about 32,000 grams per ton silver within this vein. Sampling conducted this summer was only able to get up to about 800 grams per ton silver, but nonetheless, it does correspond very well with this other chargeability anomaly. And we're going to be flying a SkyTIM conductivity survey over this entire area, the whole property, as a matter of fact. And then stepping over the fault, we get onto the eastern anticline where we have Red Lightning. That's our magmatic nickel copper deposit I'll talk about briefly. And then Spearhead, which is another poorly explored VMS deposit, which we'll be looking at more in 2021. So looking at TET and C10, it's in very rugged terrain. Here is a photograph of the silver sulfur salt vein at TET right here. So we're going to be mapping this out in detail this summer and then placing drills onto this outcrop and really trying to define this vein. But we also have examples of our 315 degree striking structures here where you have these, somewhat foliated green schist metamorphosed andesites. And then you have these intensely foliated zones with a very strong oxidation here. And when we compare where these really foliated zones, how they compare with our grade shells and drill core, it seems that these really foliated zones are lining up very nicely with our grade. And it's possible that these could be because we're dealing with our mudstone horizons here that have been more metamorphosed, and that the phyllosilicate minerals within the mudstone would be more prone to developing foliation than our andesitic rock package surrounding these zones. So looking at the drill core itself here, this is from our greater than 100 gram per ton zone here, where we see a very strongly foliated rock. The primary mineralogy is pretty much been obliterated by hydrothermal alteration and green schist metamorphism. The grade of metamorphism increases to the south, with Sib and Lulu in the north being very weakly metamorphosed, and then progressing southward, there's more flattening of clasts, which we see at TV and Jeff, and then you get into this intensely foliated rock down at C10, which we do see a lot of euhedral to subhedral pyrite, carbonate alteration of calcite and ferro and dolomite, epidote, and there's a euhedral hydrothermal quartz as well. We do get some basaltic intervals here that are more characterized by intense chloridization and iron dolomitization. Some of the pyrite within it shows pressure shadows, so you can see some ductile deformation features here. And then most of these rocks are cross-cut by calcite. So there is some metamorphic overprinting of these rocks. However, it does seem that the gold grid does correspond with our pyritic zones right here. So looking at C10 some more, we're assuming that these are basically a continuation of the TV and Jeff trend to the north. However, as I said, it's more metamorphosed than at TV and Jeff, but it's, they're both lying on the east limb of the Eskay anticline. They're both lying within intermediate composition volcanic rocks, and this is something that we've been able to confirm with geochemistry. Our lithogeochemical samples have shown that we are indeed in the exact same stratigraphy as at TV and Jeff, able to tease out that we do have andesitic intervals, dacitic intervals, and basaltic intervals that are difficult to distinguish in hand sample. It can be done, but it's difficult. But geochemically, they stand out very well, and they do line up pretty good with what we see at TV and Jeff geochemically. So stepping across our hypothesized thrust fault zone here, we get into our GFJ showing, never been drilled before. However, we do have several good historic surface samples, some around 10 grams per ton, another one getting up near 40 grams per ton gold, and all running quite good with silver. These also correspond with IP chargeability anomalies as well. So these are anomalies that we're going to be putting some exploration drill holes in this year to actually see what this is. But at this point, I would say what we're dealing with is our western limb of the eastern anticline right here, but probably going to be in similar stratigraphy that than we see elsewhere on the property with our favorable Hazelton group stratigraphy. So talking about property-wide stratigraphy now, we've been able to show that we are stratigraphically in the same horizons as Eskay Creek. Not only do we have evidence for the contact mudstone on our property, haven't drilled in any mineralization on the contact mudstone yet, but when we get into these lower stratigraphic levels, we do have our Lulu zone, which is at the same stratigraphic horizon as the lower mudstone at Eskay Creek. And then we have our Bruce Glacier mudstone horizon, which we see some examples of along strike corresponding to the lower mudstone at Eskay Creek. So we're seeing the lower parts of these hydrothermal systems that exist at Eskay Creek, and it's quite likely that these continue up section. They just need to be explored as such. And then again, we've shown that in addition to what they're drilling up at Eskay Creek, we've got our Spat-CZ zone, and then several additional zones going down into our arc-related Betty Creek Formation rocks here. So, it's not just the contact mudstone anymore. There are numerous horizons along the limbs of these anticlines and this fold thrust belt, which opens up a lot of possibilities for exploration. So we're able to correlate stratigraphically SIB on the western limb of the Eskay anticline with our TV showing here where we have our Betty Creek Formation and Spatsizi Formation rocks here that have been drilled at TV correspond to what we're drilling at the lower parts at SIB. And then working our way up section, we're inferring that we have our felsic horizons at TV just based on the geomorphology. And this is something we're going to be, confirming as soon as we can this summer. But then moving to Jeff, which is just a little bit north of TV, what we found is that we're actually intercepting stratigraphically deeper at Jeff here, where the upper zone here at Jeff is actually corresponding to everything that we see here at TV. And then we also have a additional lower zone at Jeff. Again, at TV and Jeff, both these zones are correlated with pepperitic dacite. And then moving to C10, by using the historic drill core, the re-logging that I did this summer, and the geochemical sampling and data that I collected this summer, able to show that, again, we have these similar dacitic units also associated with thin layers of basalt at C10 that are identical to what we see at Jeff and TV. So again, we're dealing with the same stratigraphic position further to the south at TV and Jeff, which is going to show that, the Eskay anticline has a lot more prospectivity on it than just looking for the contact mudstone at Eskay Creek. And we're also able to show that a handful of drill holes and a historic surface sampling is really delineating these anticlines, which were previously unmapped. So talking about our eastern anticline, if we go to the east limb of the eastern anticline, here we have our spearhead showing right here. This would be at our Spatsizi Formation, Bruce Glacier felsic unit contact. So what we've got here are these mudstones outcropping on the surface. Sampling as indicated, these get up to about 4 grams per ton on the surface. Just down section from these is our Spatsizi Formation volcaniclastic conglomerates. And then you can see our mudstone, our horizon itself has a lot of silicification and tends to form this kind of a gossinous bluff right here that goes along strike for at least 100 meters. There has been previous drilling here. However, the people operating decided that they would step 100 meters up section from the mudstone and drill, and they missed everything. They didn't encounter anything. They found the mudstone, but they didn't drill into where the mineralization was outcropping on the surface. So, we're probably just going to plan to drill right into the outcrop. That way, you can't miss it because it's on the surface, and explore spearhead to see just how big this thing is. We did do IP surveys here, and again, we're seeing the same sort of IP anomalies that we're seeing at TV, Jeff, and C10, of which our known outcropping sulfides are corresponding to this anomaly here. And we're going to have to put drills in the ground to test to see whether we're dealing with our lower mudstone, contact mudstone, and our Betty Creek Formation zones down here. We don't know that yet, but it is possible that that's what we're dealing with on this IP survey based on what we see elsewhere on the property. Red lightning is our magmatic nickel, copper, gold, and palladium deposit. I don't necessarily think it's economic. It's not very large, but we do have another potential occurrence of this on the western part of our property, adjoining Garibaldi Resources iron nickel deposits. And I'm interested in this because it's hosted by a gabbro. And when I logged this, I was able to confirm that this gabbro is actually cross-cutting or intruded into our Betty Creek Formation andesites, but is itself cross-cut by the Willow Ridge basalt, which puts us within the window of time that the VMS systems were forming. And it's possible that this gabbro is actually representing that rift-related intrusion that's driving the VMS systems as a whole. So that's something that we want to investigate more from an academic and genetic model perspective, is where does this Gabbro fit into the whole VMS system, because it certainly seems to be timed right to be part of that VMS system. I'm looking at red lightning drill core here. This is all drilled back in 2008 and earlier. What we see is our kind of green schist metamorphosed gabbro with abundant pyrrhotite and chalcopyrite here, getting up to massive pyrrhotite with disseminated chalcopyrite and other nickel sulfide minerals, as well as some palladium. And it's uncertain what the mineralogy is of the palladium at this point, and we'll have to do some electron microscopy on that. However, we will be including this within our mapping program, given its location close to Spearhead and GFJ on the eastern anticline. So we did a BLEG sampling survey in 2020. The basin was designed by Corey Beaver of BOA Exploration. And Quentin Hinney is really kind of the driver behind having this done. There was a lot of naysayers up in BC that said it could not be done in steep terrain like we have here. However, thanks to our great field sampling team, we were able to pull it off and actually come up with some very fantastic results. So as Quentin would tell you, any showing over 10 parts per billion in BLEG sampling, so 10 ppb gold is a good sample here. So I guess I should point out, for those of you who are unfamiliar with BLEG, what we're dealing with are looking for gold atoms that have been adsorbed onto clay particles. This eliminates the kind of nugget or placer type deposit enrichment effect, and actually gives you a more accurate representation of the elemental composition of material coming from upstream. So what we've been able to show here are that we've got our really fantastic results. Like if 10 ppb is good, 156 ppb is amazing. That's down within our PET C10 Spearhead red lighting. This whole area right here is just really jumping out. We also get additional mineralization, or excuse me, additional good BLEG hits along the western limb of the Eskay anticline south of Cumberland that need to be explored. And then we have these really good showings that are up here to the northeast right here. And this is actually what got me to start looking at the structural geology of the region. And realize that we're actually dealing with another anticline up here, of which this stuff right here is defining the eastern limb of our eastern anticline. And then we actually continue off over here. There's an anticlinorium called the McTagg anticlinorium that continues off of our property. But this is really defining that favorable Hazelton group stratigraphy over here as well. And this does coincide with a trend of good historic surface samples that continue further down here. So this is something that we will be mapping, sampling, and putting some exploratory drill holes over in this area later. But it's really opened up our property to a lot of new targets here. We've got 3 anticlines and 2 limbs on each anticline to explore. We have here up at the top here is our eastern anticline, the east limb that I was just talking about, those really good BLEG results. We will be placing a series of drill holes in over here. There has been some historic drilling done near some of these magnetic anomalies. This is a magnetic survey here that did intercept up to about 3.7 grams per ton. However, given the BLEG results, it's quite likely that there's something way better than that along this trend. So we'll be drilling that. we'll be drilling the southern end of this trend that's just across this thrust fault to the east of TV and Jeff. And then on the eastern anticline, we did get some overlap with our SkyTIM conductivity survey, and we're able to show we have very similar conductivity anomalies to what we see at TV and Jeff here. So we'll be drilling those as well on the western anticline. So a lot of targets. So next summer's geological program is a minimum of 30,000 meters. The only reason we won't drill over 40,000 meters will be because of weather. And we're going to perform downhole EM surveys on select holes. This will allow us to look for electromagnetic anomalies within about 50 meters of each of our drill holes. So say we miss a sulfide body, because these things are discrete lenses, usually less than about 100 meters across, you could just miss one of these things. So we'll be able to look at our EM results within, a couple of days while the drill is still on the pad. And if we see an anomaly that's pointing us in a vector towards a body, a sulfide body or conductor, we're going to drill over there. We're going to be doing oriented core. That's never been done on the property before. And that's really on some of the longer drill holes I've planned to get the contact attitude and really the structural geology figured out on each of these anticlines. And then we're going to be using our handheld XRF to ensure the quality of all the core logs. We're getting our SkyTIM conductivity survey of the entire property. So this is an airborne survey like what we did at TV and Jeff, and it seems to be doing really well at picking out zones of mineralization. We'll have the ability to do very limited IP surveys along select lines that, areas we've identified in mapping or with drill holes that we think may give us some, deeper, abilities to interpolate mineralized zones using IP. And this is something we've completed half of this year, and we'll finish this in 2021 would be our LiDAR and ortho imagery surveys of the entire property. This will really help us facilitate geologic mapping of the property and getting a drill hole collar positioning and orientation dialed in really accurately. But I will say one of our planned drill holes intercepted the drill hole it was trying to intercept. And we actually have a piece of drill core with the other drill hole running right through it. So we actually ran into a drill hole that we drilled this season. And then we're going to be doing detailed geologic mapping of these full thrust ramp complex. That's really, the quality of the mapping that's been done so far on the property is lacking, to put it mildly. So we really need to get a good geologic map going here on the property, and that's starting off with our full thrust ramp complex is kind of what we've developed so far. Now we just need to fill in the details. And then follow up leg sampling. So we'll sample sub-basins, and then we're going to do reconnaissance mapping of prospective targets identified within these basins. And then some of them, like our zones up to the northeast, will be drilled this season. So it's going to be a busy geologic program this year. And with that, I'd like to thank you for your time, and I'd be happy to take any questions. Thank you.